It can leave the system or get absorbed by a non-fissile material, in which case it no longer takes part in the chain reaction, and so it ends its Markov chain. Or it can strike another uranium-235 atom, triggering a fission event and releasing 2 or 3 more neutrons that then start their own chains. But in this chain, the transition probabilities aren't fixed. They depend on things like the neutron's position, velocity, and energy, as well as the overall configuration and mass of uranium. So a fast-moving neutron might have a 30% chance to scatter, 50% chance to be absorbed or leave, and a 20% chance to cause fission. But a slower-moving neutron would have different probabilities. Next, they ran this chain on the world's first electronic computer, the ENIAC. The computer started by randomly generating a neutron starting conditions and stepped through the chain to keep track of how many neutrons were produced on average per run, known as the multiplication factor K. So, if on average 1 neutron produces another 2 neutrons, then K is equal to 2. And if on average every 2 neutrons produce 3 neutrons, then K is equal to 3 over 2, and so on. Then, after stepping through the full chain for a specified number of steps, we collect the average K value and record that number in a histogram. This process was then repeated hundreds of times and the results tallied up, giving you a statistical distribution of the outcome. If you find that in most cases K is less than 1, the reaction dies down. If it's equal to 1, there's a self-sustaining chain reaction, but it doesn't grow. And if K is larger than 1, the reaction grows exponentially and you've got a bomb.
With it, von Neumann and Ulam had a statistical way to figure out how many neutrons were produced without having to do any exact calculations. In other words, they could approximate differential equations that were too hard to solve analytically.
All that was needed was a name for the new method. Now, Ulam's uncle was a gambler, and the random sampling and high stakes reminded Ulam of the Monte Carlo casino in Monaco, and the name stuck. The Monte Carlo method was born.